This is section R.2, and we're going to go over sets of numbers. The natural numbers are the numbers that you can count. 1, 2, 3, 4, and they continue on forever in that fashion. The whole numbers are different than the natural numbers because it contains 0. So that's the only difference between whole numbers and natural numbers. We have an extra 0, and then we continue to count 1, 2, 3, 4, and so on. The integers are the whole numbers, but we also add the negatives. We have -1, -2, -3, in addition to the whole numbers. The rational numbers are of the form p over q, such that p and q are integers, where q cannot be 0. Essentially, rational numbers are fractions. Anything that can be written as a fraction is considered a rational number. We have numbers like 2/3, 1/4, but 5 is also a rational number because you could write it as 5 over 1. Essentially, rational numbers also includes the integers, whole numbers, and natural numbers within that set. Irrational numbers are real numbers, but not rational numbers. Examples of this include pi, e, or the square root of 2. These are examples of irrational numbers. They're real numbers, but they're not rational. They cannot be written as a fraction. Real numbers are of the form x, such that x corresponds to a point on the number line. Anything on the number line is considered a real number. So you have infinite possibilities between 0 and 1, and this thing continues on forever in either directions. Anything that can be written on the number line is a real number. Now we'll get to things that are not real later on in the semester. Those are the complex numbers, which we will introduce later. Let's consider the set A, -8, -6, -12/4, -3/4, 0, 3/8, 1/2, 1, the square root of 2, the square root of 5, and 6. We want to list each element belonging to the following sets. Part A, the natural numbers. I'll use the symbol n to denote the natural numbers. And in this case, the natural numbers are 1, 2, 3, 4, and so on. So we have 1 is a natural number, and 6 is a natural number. Remember, a natural number has to be a positive number that starts from 1. So we have just 1 and 6. Part B, list the whole numbers. The whole numbers also include 0. So we have 0. And I'll use W to denote the whole numbers. We have 0 as our first whole number, 1, and 6. Part C, we're looking for the integers. For integers, we use the symbol Z for integers. And integers are whole numbers that also include negatives. So we have -8, -6, and -12 divided by 4 is also a whole number because that reduces to -3. You have 0, 1, and 6 are also whole numbers. So here is the list of integers. We have -8, -6, -12/4 because it reduces to -3, 0, 1, and 6. This is the list of integers. Remember, rational numbers are anything that can be written as a fraction. -8 can be written as a fraction, -6, -12/4 is already a fraction, -3/4, 0 can be written as a fraction, 0 over 1, 3/8, 1/2, 1. The square root of 2 cannot be written as a fraction. The square root of 5 cannot be written as a fraction. 6 can be, so these are our rational numbers. We'll use R to denote our rational numbers. -8, -6, -12/4, -3/4, 1/2, 1/6. These are the list of rational numbers. E, irrational numbers. Irrational numbers are real numbers that are not rational numbers, and there's only two: square root of 2 and square root of 5. The set of irrational numbers in our case is the square root of 2 and the square root of 5. In general, if you're taking the square root of a prime number, it would be irrational. The square roots of prime numbers are irrational. Part F, real numbers. All of these are real numbers. Set A is going to be a real number. A real number is anything that can be written on the number line, and all of these can be written on the number line. So all of these are real numbers. In this diagram, we can see the relationship between natural numbers, whole numbers, integers, rational numbers, and irrational numbers. If you look, the smallest set here is the natural numbers, and that's completely contained inside the whole numbers. For the whole numbers, we're just adding an extra 0 with the natural numbers. Integers, we're adding the negative whole numbers in addition with the natural numbers. For the rational numbers, those are just fractions, any fractions, including negative fractions. On the other side, we have the irrational numbers. These are numbers that are real numbers that can't be written as fractions, but they can be drawn on the number line somewhere. Let's review exponential notation. If n is any positive integer and a is any real number, then the nth power of a is written using exponential notation as follows. A to the n is equal to a times a times a all the way up to n a's. For example, if I have 3 to the 4th, this is equivalent to 3 times 3 times 3 times 3 4 times. If I have 5 to the 2nd power, or 5 squared, this is equivalent to 5 times 5. 7 cubed, or 7 to the 3rd power, is equivalent to 7 times 7 times 7 3 times. For any other power besides a 2 or a 3, we will pronounce it as the 4th, 5th, 6th, or 7th power. But in general, when we're squaring a number or raising it to a power of 2, we say squared. When we're raising it to a power of 3, we can say it's cubed or raised to the 3rd power. In all of these examples, the number on the bottom is known as the base. The number on the top, that's slightly smaller, is known as the exponent. Here the 5 is called our base, and this 2 is called the exponent. The 7 is called the base, and the 3 is called our exponent. Example 2, evaluate the exponential expressions. Evaluate each exponential expression and identify the base and the exponent. For part A, the base is going to be equal to 4, and the exponent is equal to 3. So we have 4 raised to the 3rd power, and that's equal to 4 times 4 times 4, and we can simplify that with a calculator. That's just 64. For part B, we have -6 raised to the 2nd power. The base is equal to -6. Notice the parentheses is around the -6, so the base is -6, and our exponent is just 2. So -6 squared is equal to -6 times -6, which is positive 36. A lot of people make the mistake of forgetting the -6 times -6 is positive 36. Part C, we have negative 6 squared. In this case, the base is just 6. There's no parentheses around the negative 6, so the 2 only affects the 6. The base is equal to 6. The exponent is 2. So negative 6 squared is equivalent to negative 6 times 6. Notice I'm multiplying the base times the base. This negative is not affected by the 2 because there's no parentheses. Make sure you are aware of that. This simplifies to negative 36. So the difference between part B and part C is all about the parentheses, and it makes a huge difference. Part D, we have 4 times 3 squared. In this case, the base would be the 3. This is going to be my base, and the 2 is the exponent. So 3 squared, that's 3 times 3, so it's 9. So we have 4 times 9, and that reduces to 36. In part E, the base is 4 times 3. The exponent is 2. For part E, I have 4 times 3 squared is equal to, well, I could do the multiplication first. 4 times 3 is 12. 12 squared is just 12 times 12, or 144. Orders of operations. If grouping symbols such as parentheses, square brackets, absolute value bars, or fraction bars are present, begins as follows. Step 1. Work separately above and below each fraction bar. Step 2. Use the rules below within each set of parentheses or square brackets. Start with the innermost set and work outwards. If no grouping symbols are present, follow these steps. Step 1. Simplify all powers and roots. Work from left to right. Step 2. Do any multiplications or divisions in order. Work from left to right. Step 3. Do any negations, additions, or subtractions in order. Work from left to right. Now, a lot of you are probably familiar with Pemdas, and that's what I usually use for these types of problems. The P tells me I have to start with parentheses, brackets, curly brackets, or other grouping symbols. The E stands for the exponents. I have to do those next. The M is for multiplication, and the D is for division. Now I like to put an underline for the multiplication and division and a little arrow, because I have to do these in order from left to right. A lot of people forget that. You have to do this from left to right. The A stands for addition, and the S stands for subtraction. And again, I put an arrow underneath the addition or subtraction because I have to do that from left to right. Again, your P is your grouping symbols. Could be parentheses, could be brackets. E are exponents. M and D is multiplication and division. I want to make sure I do this from left to right. This one, addition or subtraction, I want to do it from left to right again. So let's get started with orders of operations. Part A, we have 6 divided by 3 plus 2 cubed times 5. Now I will write the orders of operation up here so we can remember it. I'll look for parentheses first. There are no parentheses in this question, so we'll go down the list. Exponents, there's one right here. So we have 6 divided by 3 plus 2 cubed is 2 times 2 times 2. And that just simplifies to 8. So this is 8 times 5. Now, there are no exponents. I'll move on to the next thing, which is multiplication or division from left to right. So I'm going to do the division, then I'm going to do the multiplication. It says from left to right. 6 divided by 3 is 2. 8 times 5 is 40. Then we have No more multiplications or divisions. We'll move on to addition or subtraction. And there's only one here, so it's 42. Our solution for part A is 42. Part B, we have 8 plus 6 divided by 7 times 3 minus 6. Again, I want to start with the parentheses. In this case, we have 8 plus 6 is 14. Then I'll move on to exponents. There's none here. Multiplication and division. Again, we go from left to right. Then we'll do the division first. 14 divided by 7 is 2. Then we'll do the multiplication. 2 times 3 is 6. And there's only subtraction left. 6 minus 6 is 0. For part B, our solution is 0. Again, don't make the mistake of doing the multiplication first. Remember, it's from left to right. So I have to do division before I do multiplication in this case. Part C, 4 plus 3 squared divided by 6 minus 5 times 3. I like to focus on the top first, then I'll do the bottom. I have no parentheses, but I do have an exponent on the top. That's 3 squared, which we know is 9. 4 plus 9 divided by 6 minus 5 times 3. I'll still do the top first. 4 plus 9 is just 13. And since the top is done, now I can focus on the bottom. I'll do the multiplication first because that's next on the list. This simplifies to 13 over 6 minus 15. And finally, we just have an addition or subtraction. 6 minus 15 is negative 9. And here's our solution, 13 over negative 9, which you can simplify as negative 13 over 9. Part D, we have negative 3 squared plus negative 5 over 2 times negative 8 minus 5 times 3. If you look at this problem, be very, very careful. There is no parentheses in this question. It looks like there is, but in fact there's none, because if you look, these are just multiplications down here. This is just an exponent, and this is in fact an addition of a negative. To be considered a parentheses, there's gonna be something inside that you have to do, like this. 5 plus 4 is considered a parentheses because we can add 5 plus 4. But 5 times 4 is not a parentheses because that's really a multiplication. So be careful, this doesn't have any parentheses. It does have exponents, however. So we'll do negative 3 squared. We'll do negative 3 squared first. Now, the base is negative 3. So we're raising negative 3 to a power of 2. And that's going to be a positive 9. Negative in the front with a positive 9 afterwards, plus negative 5 divided by 2 times negative 8 minus 5 times 3. Now I'm going to do the top here. We have negative 9 plus negative 5. That simplifies to negative 14 over 2 times negative 8 minus 5 times 3. Now we can simplify the bottom. We have two multiplications here. I have negative 14 divided by negative 16 minus 15. Again, I'll simplify the bottom. So we have negative 14 divided by negative 31. And the negatives do cancel out, so our final solution is 14 over 31. Example 4. Evaluate each expression for x equals negative 2, y equals 5, and z equals negative 3. So we're essentially going to plug in these values for the letters in the problem. So let's look at part A. I'm going to replace that x with a negative 2. I'm going to replace the y here with 5. and we're going to replace the z with negative 3. According to our orders of operation, I have to do the exponent first. These aren't considered parentheses, so we'll do the exponent first. We have negative 4 times negative 2 squared, that's positive 4. And I'll just copy down the rest. The next step is our multiplications or divisions. And in this case, we have this we need to multiply, this we need to multiply, and this we need to multiply. We'll do that from left to right. Negative 16 minus 35 minus 12. Negative 4 times 4 is negative 16. Negative 7 times 5 is negative 35. 4 times negative 3 is negative 12. And then we can select like terms and add all of these numbers up. And we have the sum of this is negative 63. Part B, we'll again do substitution for x, y, and z. We have 2 times, in this case let's replace x with negative 2. I'm going to replace the y here with a 5. And on the bottom we have negative 3 plus 4. I forgot the square term here, so let's put the square term here on the top. And now we're going to simplify. In this case, we do have a parentheses. I have negative 2 minus 5 is considered a parentheses. Negative 2 minus 5, that's negative 7. I'll just copy the rest for now. And focus on the top. I have an exponent here. So let's simplify negative 7 squared, which is positive 49. I'm going to simplify the top. I have 2 multiplications I should do next. 2 times 49 is 98. And 4 times 5 is 20. Now I could simplify the top. 98 plus 20 is 118 over negative 3 plus 4. And finally I can simplify this is equivalent to 118 over 1. And that reduces to 118. Part C, again I'm going to do substitution with x, y, z into these letters, and we'll simplify from there. We have negative 2 divided by 2 minus 5 over 5 over 3 times negative 3 over 9 plus 8 times 5 over 5. So replace all of these letters with the numbers and we'll simplify. I always like to start with the top first. Negative 2 over 2, that's just negative 1. Negative 5 over 5, that's just negative 1. And I'll leave the bottom alone. Let's simplify the top again. We'll simplify negative 1 minus 1. Now this simplifies the top as negative 2. And on the bottom, I'm just going to copy it down. You're always welcome to simplify the bottom at the same time if you want to. Now we'll simplify the bottom. Negative 3 times 3, that's just negative 9. So negative 2 divided by negative 9 over 9. 8 times 5 is 40 over 5. Now we can simplify this a little further. Negative 2 over negative 1 plus 40 divided by 5 is 8. And so we finally simplify this as negative 2 over 7. So our solution is negative 2 over 7. In this example, we want to use the commutative property or the associative properties to simplify the expression. The commutative property is essentially saying that if you have a plus b, you can rewrite it as b plus a. So you can switch these terms around and it will not make a difference for addition. It also works for multiplication. A times B is the same as B times A. So the commutative property just says you could switch things around but still get the same solution. The associative property is a similar property in the sense that we have multiple terms. I can add the first two together, then add C. It's the same as if I added the last two together, then add A, I would still get the same solution. So the associative property means we can move the parentheses around for certain things such as addition, and it also works for multiplication as well. If I multiply A times B with C, that's the same thing if I multiply the B times C first, then multiply with A. So the associative property works for both addition and multiplication. The commutative property works for both addition and multiplication also. Be careful with subtraction. It doesn't work with subtraction. So let's try part A. We have 6 plus 9 plus x. And the 9 plus x is in parentheses. Well, according to the associative property, I can move the parentheses to the 6 and the 9. So 6 plus 9, that's easy to do. That's just 15. And we can add x after. For part B, we have 5 over 8 times 16y. Now, according to the associative property, again, we can move the parentheses around. So this is equivalent to 5 over 8 times 16y. And 5 over 8 times 16y, I can reduce the fractions. This 8 reduces to a 1. The 16 reduces to a 2. So 5 times 2 is equivalent to 10. And we have a y. So our solution for B is 10y. For part C, we have negative 10p times 6 over 5. I can use the associative property to switch this around. So this is equivalent to negative 10 times 6 fifths times p. And of course, I can reduce these fractions. 5 reduces to a 1. 10 reduces to a negative 2. And so we have negative 2 times 6 is negative 12. And we have a p. So our solution for part C is negative 12p. Example 6, we'll use the distributive property. The distributive property says if I have A times the quantity B plus C, I'll just have to multiply A times B, and then we'll multiply A times C and add it together. Once you do the distribution, you have to remove the parentheses. Part A, we have 3 times the quantity x plus y. I'll multiply 3 times x, that's 3x. 3 times y, well, that's just 3y. For part B, we have a negative in the front, so that's negative m minus 4n. I like to pretend these negatives are negative ones. So we'll put a negative 1 in the front, and then multiply by m minus 4n. Let's distribute the negative 1. Negative 1 times m is negative m. And negative 1 times negative 4n is positive 4n. For part C, we want to rewrite this using distribution, so we'll go the other way. I can see that the 7 is multiplied to the p, and I could also take a 7 from the 21. I can write this as 7p plus 7 times 3. And using reverse distribution, we have 7 in the front, and then p plus 3 on the inside. For part D, I have 1/3 times 4/5 m minus 3/2 n minus 27. Again, we're going to distribute the 1/3. This is equivalent to 1/3 times 4/5 m. This is 1/3 times negative 3 over 2 n And this is 1/3 times 27, a negative 27. Let's simplify this expression. I can't reduce the 3 or the 4 and the 1 and the 5. So let's just multiply straight across. This becomes 4/15 m. 1/3 times negative 3 over 2. I can reduce the 1. I can reduce the 3 into a 1, that is. And then this 3 also reduces to a 1. Multiplying it all together, I get negative 1/2 n. And the 1/3 times 21, I can put a 1 underneath. Reduce this to a 1. Reduce this to a negative 9. And so it simplifies to 4/15 m minus 1/2 n minus 9. We'll look at the definition of the absolute value. For the absolute value, we use these vertical bars, and this is pronounced the absolute value of A is equal to A if A is greater than or equal to 0. It is equal to negative A if A is less than 0. Basically what this is saying is, if A is a positive number, we'll keep it. If A here on the inside is a negative number, that is a number that's less than 0, then I want you to multiply it by a negative. What that means is, if it's a negative number on the inside, and we're multiplying it by a negative, this thing is going to be positive. So the absolute value is going to represent a positive number. For example, the absolute value of negative 3 is positive 3. We have to multiply this negative by a negative 1 to get a positive 3. The absolute value of negative 7 is positive 7. We want to make sure the absolute value of any number is positive. The absolute value of 12 is 12. It's positive, we keep it. If it's negative, we make sure we change it to a positive. So again, the absolute value of any number is always positive. Make sure the absolute value is always positive. Part A, I wanted to find the absolute value of negative 5/8. Well, I know the absolute value is a machine that changes all my numbers to positive numbers, so it's going to give me 5/8. Part B, I know the absolute value is going to keep that 8, but wait, there's a negative that's on the outside, so we'll have to include it. So for part B, the answer is negative 8, because the absolute value is done first, and the negative just follows along. For part C, I have to do the absolute value first. That gives me positive 2, and this negative here is just there to follow. So do the absolute value negative 2 first, and you should get positive 2, but the negative has to follow. For part D, we have the absolute value of 2x for x equal to pi, so I'll replace the x with pi. And since this is already positive, we're going to keep it, so the absolute value of 2 pi is just 2 pi. Example 9, we're going to do evaluating with x equals negative 6, y equals 10 in the following expressions. For part A, again, let's replace these letters with our numbers. We're going to replace x with 6, and we're going to replace y with 10. Let's simplify the inside. I have negative 6 times 2 here. That's going to give me negative 12. And negative 3 times 10 is negative 30. Negative 12 and negative 30 together is negative 42. Don't forget the absolute value. The absolute value of negative 42, we're going to change that to a positive 42. And that's our solution for part A. Part B, I'm going to replace this x, y, and this xy with our numbers. We'll replace the first x with a 6. We'll replace the second y here with a 10. And we're going to divide that by negative 6 times 10. I'll take all of the absolute values first. So let's look at our orders of operation. We'll look at our parentheses, and in this case we do have parentheses. Remember, absolute values also count as parentheses. So the absolute value of negative 6 is positive 6, so we'll replace that with a 6. And when you replace an absolute value with a number in front, consider that multiplication. We have 3 times 10, that's going to be 30. Negative 6 times 10, that's going to be negative 60. I'll simplify now. 2 times 6. I'll simplify all of the absolute values now. Absolute value of 30 is just 30, but there's a negative in the front, so bring that down. The absolute value of negative 60 is positive 60, so now we can simplify this. 2 times 6 is 12. And so now 12 minus 30 is equivalent to, the top simplifies to negative 18, and we have 60 on the bottom. Notice that they both share a common factor, so let's divide the top and the bottom by 6. This finally reduces our solution to negative 3 over 10.